Welcome back to Coding on Swiboe, the next generation text editor. So, uh, public service announcements? None. This week is a regular week, so we have 5 streams on every workday at 8 a.m. in the mornings, European time. And yeah, nothing else happened during the weekend. I was traveling again, so no work on Swiboe. And we were actually working on documenting stuff, and we continue working on that too. So, where were we? We already had Swiboe client context receive. Yes, we documented that. Now we document this here. What is that actually doing? Returns true if the given C result is a success. The OK value, maybe like that. You can get to the result using Swiboe RPC result unwrap. If this returns false, or RPC result unwrap error, right? That's the two functions that you can use. The given here is not really needed. Returns true if the RPC result is an OK value. You can get to the result using Swiboe RPC unwrap error. That's true. And this is not consuming the value, of course. This here though is unwraps RPC result and returns the contained string. Is that leaking memory again? I feel it might be. Right, we create a C char string. Maybe not. I'm not sure. JSON result string. Unwraps RPC result and returns the contained JSON result string. So JSON probably has capital letters and crashes if RPC result is not a OK value. Okay, and here we do exactly the same. Oh, consumes RPC result, deletes RPC result. Let's put it like that. And this one is exactly the same. We did this no-com. We will do this no-com now. Unwraps the RPC result and returns the contained error. Crashes if RPC result is a OK value, deletes RPC result. Right. So what else do we have? C callback. Actually, I would like to have this at the top. Somewhere around here, maybe. Wraps the callback type for RPCs so that C clients can implement them using a single C function. That's what we do here, right? Looks like it. Okay, and then down here we have remaining only this one. This is creating a new RPC and new RPC implementation for RPC name. With with the priority and the function and the implementation callback. And C callback we actually have to, yeah, that's fine. I think that's fine. I think that documentation is sufficient. Actually, I believe that the Python code is still better documentation than what we wrote down here, but everything is now documented. So how are we looking then? In the C client, what about to-dos? Okay, so we don't have cancel wrapped. We don't have Windows support, and at this point, I'm unsure about returning here. I'm unsure about this, right? I'm returning a C string here, and I'm not sure if actually Python properly frees that or not. But I guess it does. So for now, let's add this to do somewhere here too, where I actually was concerned too. So for example, here, and up here. I'm not sure how to figure that out even, right? Does the CLAN free the return value correctly? I would need a Rust expert to actually understand if this is like valid or not. Maybe we have to change this API eventually to return some sort of wrapped object that you then have to delete. But for now, let's leave it like that. Actually, maybe we can just figure out how C string is implemented, right? I mean, we have to set it JSON to string, then we have the C string new. So what is that actually doing? Maybe we can find that. Rust nightly C string new. Here. So let's look at the source of this thing. Oh shit. Hey parts, sorry to hear that. Hope you're feeling better. That sounds horrible, man. So this is a box to U8. Yeah, I'm really not sure. So basically, what do we do here? From vector unchecked. Yeah, actually, that's the philosophy way to look at it, parts. It was a crazy experience. So where's interraw? Here's interraw, right? So I think that's actually, yeah. Ugh, shit. There it actually says very explicitly, the pointer must be returned to Rust and reconstituted using from raw to be properly deallocated. Specifically, one should not use the standard C free function to deallocate this string. Ah, damn it. So actually we are leaking memory. That's really bad. That also means that we need to change our API. And the API will not get prettier through that, right? So basically, wherever we are using cchar pointers, which we do basically everywhere, wherever we passing ownership, that is basically, so that won't work. So here it's fine because we're not taking ownership. That's fine. But here though, no, that's fine too. We're not taking ownership. Yeah, we're not taking ownership. That's fine. Here too, we don't take ownership. Here we don't take ownership either. No, we don't take ownership. Oh, maybe it's not that bad. Maybe, oh, there we go. Here it's bad, right? So this is actually what we did before. We passed in a pointer to a C string, and this we actually then used So we use that in the Python code, and then I was expecting the Python code to call free on that, but actually that is not working. We cannot actually do that. We have to reconstitute the C string that we use down here. We have to reconstitute that object so that Rust can properly free it. And now I'm really unsure how to handle that, right? What is a nice API to look into? Like, how should this look? Ugh. Yuck. That's really, ugh. That's really not pretty, you know? Really not pretty. The problem is what I would really like to have is something like, let's copy that so I can show you. So something like this would be nice, right? That we have something like, we take a mutable pointer to a like a const pointer to some class, our rep string class, something like this, right? And then our rep string class that can do something like actually impl drop for rep string, something like this. And then we can say inside of here, like when this is dropped, rep string self, I think it's probably mutable self, something like this. Then I don't actually need this, right? Like so. And here we do some sort of assert has been freed before, right? Something like this. Actually, I think we can probably do that, right? And then we can have something like impl rep string fn get char pointer or so, and that actually returns our const char, like a const pointer to a c char or something like this. And that would probably not look like that. It would probably be something like a pub extern cfn Swiboe rep string get pointer. That would look like this, and that's probably exactly the solution that we need, right? And then we can oh no, that won't work, right? if ah that's so ugly, right? Because if we return this rep string and our users never actually call a drop function on that one, then of course our string will, like, this drop function will never be called, and we will never know that we actually leaked some memory. That's so terrible. There's no way of actually there's no way of working around that. I mean, then it doesn't buy us anything, right? We might just as well add a single extra function that we call something like Swiboe free returns string, something like this, right? Ah, that's so ugly. And we have a C buffer here, and that is a const pointer to a C char, something like this. And basically we have to do something like C string from pointer, C buff, and that's it, right? And that will actually free that. And then we have to change the documentation here for this. Fills in C string with the new result. This has to be freed using Swiboe free string, or let's call it delete string. Ah. Ah. Here too. Unwraps RPC result and returns the contained JSON result string. This value must be freed using, must be deleted using Swiboe free delete string. I called that thing. Okay, here too. Details must be freed using Swiboe delete string. I think that's it. Only those two places we actually return a string value. But that is not pretty. Absolutely not. Absolutely not. Because we cannot know, right? If the user is not calling Swiboe delete string, it will just leak memory and nobody will ever know. All right, fine. So where are we using those thingies? Okay, so Swiboe RPC result unwrap. Here we get a JSON blob back, and then we use that JSON blob, and then we have to say Swiboe, no, self library Swiboe delete string JSON blob, right? And here two, and here two. Okay. Okay, so RPC result unwrap, and then the RPC, there must be what? How many functions? Like 3 functions actually, right? So we have the unwrap error function here too, and the unwrap error function that gets the details, and the details also have to be deleted. Self library Swiboe delete string details, right? There's no way around it. We have to delete it. And then the receive function self library delete string JSON string, like so. And here too. Here we're actually checking that we're dealing with the null pointer correctly, so that is really nice. That makes me sad. I mean, it's understandable why that is the case, but C APIs are never very pretty. So Swiboe client, no, not client, Swiboe delete string. It's our new function, and it actually returns nothing, right? And it takes as arguments, archetypes. It takes one pointer to a char. Right, and now the function is probably not working yet. Delete string, it is also not yet documented. And it has the wrong name. Swiboe delete string deletes cbuff, which must be a string that was previously passed from the C library, from the Swiboe library to the C client. Something like this. Is that understandable? I think it is. Okay, and then we actually, what happens if C string from buffer gets from raw? What happens if from raw gets a null pointer? From the Swiboe library to C client or null pointer. If cbuff is null pointer, wasn't it like that? I thought it was. Well, if it is null pointer, we have nothing to do, right? We just return. So otherwise, we actually do a unsafe mem C string from pointer, and that will then immediately get dropped. Right? That will work. So we still have wrap string somewhere, but we actually don't need that because it doesn't buy us any benefits, unfortunately. No method is null pointer. Is null. Okay. And mismatch type. That's also true. Use of unstable library features C-string memory 2 renamed from raw. Okay. Expected a mutable pointer. Why does that need to be mutable? Well, I don't care. I really don't care. Then it's mutable. Fine. Fine. Whoa! What happened? Swiboe delete string symbol not found. Of course not, because I didn't tell it to not mangle it. Ooh. Error for object pointer being freed was not allocated. Report. Swiboe delete string. Yeah, so we're calling delete string. That's fine. And that is nearly unreadable. No idea where it's actually dying. So back to minimal cases. Setup, teardown. Okay, so far so good. So far so good. So far so good. And probably here somewhere it's crashing. No, still good. So here it works, delete string, fine. Aha. Aha, aha. Ignore. So what's going on here? Swiboe RPC result unwrap returns a JSON blob, and this JSON blob, then what happens with it? Why is it not happy about deleting it? Oh, I know. I know. Or do I know? What is happening here? So we have Swiboe RPC result unwrap. What do? We have an RPC result that we actually delete after the fact. And no, that seems fine, right? We have a C string, we return that, we convert it into a raw pointer, and this raw pointer we return to the function. So we do this exactly here. So now we own this JSON blob, and then we delete it. But it disagrees. It says that we don't own this JSON blob. I'm confused. I mean, we very clearly convert the C string into its raw form, and then we never ever free it. So are you unhappy about the const? Maybe it has to be mutable? No. Is maybe Python still trying to free that? Could that be? That would be terrible. So if I say free, where is that delete pointer? So I wonder if I maybe have to tell Python that the object is now 0 so that it's not trying to delete it anymore. So in my delete string function here, I don't take a mutable pointer, I actually take a pointer to a mutable pointer. And then I say if cbuff is null, which should never ever be the case. Actually, I can assert that. Assert not cbuff is null. And now I actually have to wrap this in an unsafe block and say, well, if cbuff is null, then actually not cbuff, but this cbuff is null. Right, that's the actual string. Then we're good. The string is already freed. Otherwise, we actually free the string and we set this cbuff pointer to pointer null, right? Something like that. Null mute or mute null, something like this. Are you happy with that? Okay, so that builds, but of course now the Python definition is no longer correct. Actually, the definition must now be this is a pointer to a C char pointer, something like that. And now we have to change all the delete strings. So here we actually, we pass C types by ref. details. And here too, C types by ref. And I will actually not only free the memory, but also null the pointer. So it might now work. What? Okay, so that's really stupid. What are you doing to me? Why are you doing that to me? 100, 180, 38, right? So here, Swiboe RPC result unwrap. How is that defined? It is defined to return a C char pointer, and it is implicitly converting that to a string. I guess this is just not working the way I was hoping it would work. Okay, so we're half an hour in, so I call defeat for today. I add a new com here. We cannot return a C char P because Python always takes ownership and calls free on the string. Unfortunately, this leaks memory. So we have to change this to take the pointer as an argument, similar to receive. Right, and then we can actually we can change this one back, change back again to only take pointer, not pointer to pointer. Okay, so that's it for today. If there are any questions, please post them now while I submit our changes. This change actually is broken. Partially fix memory leaks. Too bad, but at least we finished the documentation. That's something. So this is the work we've done today. And that's it. Thanks for tuning in. Tomorrow we will delete this, fix this memory leak, and then probably start on implementing cancel. And I think we'll finish the raw C client in this week. Okay, thanks for tuning in, and I talk to you tomorrow.